Well, this has probably been more than 10 seconds, so as you can see, all of them are still burning. So now, what I want to do next is, whenever we are finished with this first part of the puzzle, I want something to come out of the ground that we can actually interact with again and do a different puzzle in order to open a different door. So now for that, let's again create a new blueprint class, actor, and I'm gonna call this second puzzle. Let's open this up, and I'm gonna make this quite simple. So all I'm gonna have is a bunch of pillars. So I'm gonna select a static mesh, and let's see. So what I'm basically going to use are these chairs. It doesn't matter what mesh you are using. I'm gonna use some chairs. So I'm gonna move this out a little bit, so maybe like 100 units, and I'm gonna duplicate this one, move this back to the middle, duplicate another one, and move this one out 100 units. So now for all three of these objects, I'm going to add a box collision so we can walk inside of it and interact with that one specific instance. So I'm going to extend the box a little bit, 100, maybe 150, a little bit higher in the z-axis, and bring this up a little bit. We don't really need this too much under the ground. This seems to be good, and now we need a bunch of more for every single one of these. So the static mesh without the number is the one on the left, so I'm going to move my box to the left as well. So again, 100 units, the same location as the other object, at least in the x-axis. So then I'm going to duplicate this, move this to the 0, and then the last one is going to be at plus 100 in this case. So now we need some overlap events for every single one of these. So make sure to select your box, scroll till the very bottom, and create on begin overlap and also on end overlap, and do the same thing for all three of these collision boxes. So that's exactly what I'm doing right now. So I have all of these events ready to go, and to make life easier again, let's go back to our lighter and copy these cast and set interactable nodes and paste those into our second puzzle. Connect the execution and objects just like we did before. So the execution and the other actor casts to our character, and the only difference that we need to make is we need to set up which object we are interacting with. So basically, if it's box without a number, then we want to interact with this static mesh. So what I'm going to do is actually create a new variable, and I'm going to call this active component. And we got to make sure that then this is a static mesh component, because the components that we are trying to interact with are static mesh components. So on begin overlap, we want to set it to be our static mesh 0, well, without a number, at least this one. And then whenever we leave it, well, we can set it back to none. There we go. So now let's copy all of these nodes to the other overlap events also, like so. There we go. And now we can just simply drag and drop our static mesh 1 on top of this node. So static mesh 1 on top of this one, and this replaces it. So now again, one more for the last one. Connect the pins. There we go. And replace this one with static mesh 2. So now let's go to our class settings and add ourselves our interaction interface so that we have our start interaction event. So I'm gonna right click, event, start interaction. There we go, we have that. And then whenever we start the interaction, I want to get the active component. I want to get its relative rotation. I'm gonna split this, and then I'm also from the active component, I'm going to set the relative rotation. There we go. Let's plug that into execution. And over here, what I want to do is split the new rotation. Let's reconnect the X and Y axis, because those are not the ones that I'm going to be rotating the object in. I'm going to be rotating mine in Z axis. And you can find out your axis by selecting the mesh in the viewport and just simply rotate in the direction that you want it to be rotated, and you will see on the right side which value is changing. So in my case, that is the Z axis. So in the event graph, I'm going to do the current relative rotation Z plus float, and that's going to be the end result. I'm going to use 15 degrees on this one. There we go. So now let's try to give this a go, and let's see what happens if we bring this second puzzle into the world. Let's see, let's walk next to it. There we go. We can rotate this one. We can rotate this one. Maybe to make this thing a little bit more precise, what we actually would want to do maybe is lower the extent in the x-axis. We don't need this to be that big, otherwise it is interfering oddly. So make sure to change these values to way smaller, because this box doesn't need to be big. As soon as we overlap it, it's all good. So let's try this once more with some smaller values. There we go. So now this is working way better with smaller values. There we go. This is pretty good. So you might want to experiment with these values. It obviously depends on your game and the way that you want these things to be in. Maybe they might be in a square, but there might be more of them. They might not be in a specific line like mine are right now. Also, a small change that I'm going to make is the 15 degrees is very little, so I'm going to make this into 30 so that the rotation would go a little bit quicker. Now, one thing that I do want to demonstrate to you is if we would print out now the value of the Z rotation. So let me just get the current Z rotation and print it out. I'm going to show you the values that we are receiving. So if we rotate this object, you can see it's 30, 60, 90, 120, 180, and then it goes to minus 150, because while we are in a game world, this rotation goes from minus 180 up until plus 180. So there we don't need to use a full 360 degree rotation in the numbers. We never use 360. We always go from minus 180 up until 180, and that creates us the full rotation. And that's exactly what we need to use in the code when we are creating the functionality for actually getting the correct combination. So what I'm going to do now is set up a function which is going to check whether the code is correct. So I'm going to add a new variable, and I'm going to call this rotation code, and I'm going to make this into a rotator, and I'm going to make sure that this is an array. Also, you can make this instance editable and expose.spawn if you want to provide this from the outside, just in case if you want to reuse this exact puzzle for different objects also, because you might maybe use 5 or 10 of these blueprints in order to create your puzzles. So if it's instance editable and expose.spawn, we can provide this from the outside. But well, I'm going to provide this from the inside, and let's set up our rotation. So the X and Y should not be touched. They should be left at 0 because that's their rotation at 0. We should change the Z axis only. So since I'm adding 30 degrees, and then I should work with those numbers. And let's say I want the first one to be like minus 150. Then this one would be like minus 90, and this one would be like 90, for example. So those would be my needed rotation. So what we can do now is, after we have rotated and interacted with the object, let's bring in our rotation code and let's do a loop for each. Let's go through all of these rotations that we have in the memory, and then we have an array index. We want to do a switch on that index depending on the entry that we are in right now. And actually I'm gonna select these nodes, right click, and collapse these to a function, and I'm gonna call this check code so that we can create some local variables. So for these local variables, let's set up one, and let's call this local comp, so basically local component. For this one we can use two things. We can use a primitive component, or since I'm using static meshes, I'm going to use a static mesh component. I'm just going to specify a specific one, and this needs to be a single instance. It doesn't matter, we can also use the primitive component also. So let's set up this local component on all 3 of these indexes, because I have 3 objects, so I need 3 of these indexes. And then let's plug in our components. So the first one, the 0 one, is the static mesh 1 is for the index 1, and static mesh 2 is for the index number 2. Now what we want to do at the end of this is get our local component, and we want to get the relative rotation. So relative rotation from the local component, and we want to make sure that this relative rotation is equal to the rotation from the array. So basically the array's element, like so. Now this requires a bit of an error tolerance because the rotations are not perfect. So if we would select any of our objects and rotate, you can see it adds 0.0001. So there is a slight mistake. It's not a perfect number, so make sure you give this some error tolerance. I usually use 1 degree, and well, usually it works just fine. So then we can do an if and connect the execution to all 3 of these set local component nodes like this. And there we go. So now I'm going to add another local variable, and I'm going to call this local fail, so that this would return me a value whenever we have failed. So this needs to be then a Boolean value. By default, it's going to be false. And then if this returns as false, if the rotations are not equal to any of these instances, we are going to set this value over here at true. So local fail will be true on false. And on true, we're not going to do anything. So we're going to allow this whole thing to go through it. And then on the completion, we're going to do an if branch check, and we're going to see if the local has failed. And then over here, if this thing right here would be false, that means that everything is all good. The code has went through and has been correct. Then, well, at this point, we should then create ourselves a functionality which would then open the gates for the next room. So what I'm going to do is over here, I'm going to return, and I'm going to add an output, and I'm going to call this success. Now for false, I'm going to return true, but for true, I'm going to return false. Yeah, and that's basically it for this function right here. So we can compile and save this, go back to our event graph, and then we can do a if branch check on this check code. And now we need to provide ourselves the door actor. So what I'm going to do is add a new variable, and I'm going to call this, let's call this door actor. Let's make this, since I don't have a specific door, I'm just going to make this into an actor. I'm going to make sure this is instance editable and exposed on spawn, because we do need to provide this from the outside, because we don't have a reference to the door inside right now, but we can provide this from the outside if it is already existing in the world. If it's not, then you need to spawn it, and then you need to pass along the value to this variable right here. So on true, what I'm going to do is get my door, and I'm going to get actor location, and also I'm going to set the actor location for this same object, for this door, like so. So on true, we can do that. And then what I want to do is add a plus, so vector plus vector, and I want to add some units in the z-axis so that my doors would basically move upwards. You can use any rotation you want. I'm going to use 1 degree on this one, well, 1 unit, so I'm going to add 1 unit to this. And then once this is done, I want to again get the actor's location, and I want to check if this one is equal to basically the current location plus depending how high I need these doors to go, and I'm gonna say like, let's say like 300 units. So this is gonna be the other one. Let's add some error tolerance again, so 1 degree maybe. Then we can do an if to check if our doors are high enough, and then if they are not, then I want to do a tiny delay. So delay is usually 0.1 is a really good value, and then on completed, after the delay, I want to again set the actor's location to be plus 1 unit up until, well, basically up until it returns us true once it is in the correct location. So that's pretty much it for this one. So now let's test this thing out. So what I want to do is actually, whenever I rotate these things, I want to print out the Z location so that I would know that I do type in the correct code. So I should remember now that it is -150, -90, and 90. And then I also, in the viewport, I need to select this puzzle, and I need to select the door actor. So I'm going to select this wall right here. So basically this wall should start moving up whenever I hit the correct code. Yeah, obviously this wasn't working for me because we got to make sure that this thing right here, that our door actor, is set to be movable. So select this actor, and in its transform properties for the mobility, make sure that this is set to movable. So now let's give it a go. So this one is -150. Come on, move forward, move closer. So I should have made those boxes maybe a little bit bigger. Seems to be a bit too small. So we have put in the correct code. Let's see if this thing is opening. And you can see it is opening. Maybe we should have given a little bit more values to this because this seems a very, very slow process to get these things open. So basically what then you want to do is give in the event graph over here where we're adding just 1 unit, maybe add more units or simply lower this timer to be like 0.1. The smaller the add and the smaller the delay, the smoother the actual door opening will look. So just keep that in mind. So we have this part done. So the doors are opening whenever we finish this puzzle. Now we got to make sure that whenever we finish our pillars, that our door puzzle does come up from the ground. So what I will do is go back to my pillars. So we have our pillars actor. So now inside of here, what we should do is first create a new variable so that we can show which actor we do want to bring out of the ground. So I'm going to call this second puzzle because, well, that's the name of the other puzzle, and make sure that the variable type is the actor, and then make sure that it is instance editable and exposed on spawn, so that we can again provide this from the outside when it is already in the level. Then on our start interaction, don't move, there we go, here after the sequence 0, when we check the other pillars, we want to do an if branch check to check whether the puzzle has been finished. So check if the puzzle is finished, and then if that is true, then we can bring in our second puzzle, get the value, and then we can get the actor location. And well, I'm gonna move this under the ground. So first let's set the actor location, and that's gonna come from the true. There we go. And just like previously, I want to get the actor's location and do a +1 in the z-axis like this, +1. There we go. And then after the setting the value, I'm gonna check if, and then from the actor's location, what I'm actually going to do is break this vector, because what I want to check for is that the z value right here is bigger than 0, because the object itself is going to be underground and I want it to move up until it reaches the surface area. So that's going to be my condition, to make sure that the z is bigger than 0, because by default it's going to be at a negative value. You gotta check this these values for yourselves, and actually I see that mine are going to be wrong, because at this point the actor's location in the z is 170. So I want to check whether this z is bigger than 170, because by default I'm going to move this under the ground and it's slowly going to come out of the ground, and then we are going to be able to interact with it when it reaches this point. So now, if this value then is false, if it hasn't reached that value in the z, then just like previously, we want to do a tiny delay, and this one let's do like 0.1, just like I changed for the other one, so that the movement is a little bit quicker. And then after that, we can go back to set the location like so. There we go. And that's pretty much it. So now we can go to our viewport. Now make sure to select your pillars. Select all of your pillars, select all of them, and then check this, pick actor, and pick your second puzzle actor. Now all of these pillars will have that second puzzle variable filled with a reference to this puzzle right here. So now we can move this puzzle under the ground like so. There we go. So let's test this whole thing out. So first we got to pick up a lighter. We got to light up our pillars. So let's light up our pillars quickly, and let's wait. There we go. You can see our puzzle came out of the ground. So let's fill in the values. So let's see, this one was 90, and then this one was -90, and then this one was -150, and then you can see, there we go, the doors are opening. Now the issue is TopDown template is using a Navmesh bounce in order to walk around, and since we placed that object down, we are not able to walk through this. So let me show you a quick way how we can fix this, because if you would hit the keyboard key P on your keyboards, here you can see the Navmesh bounce that you are allowed to walk on, where you have the green squares, but over here you can see it doesn't fill this area, so we are not allowed to walk there. Because our character is an AI that simply walks on his own. We do not walk with him, we just simply tell him where to go. So there is a thing, it was called nav link proxy, and what you can do is bring those links in, place the link, usually I place it in the middle, and then simply rotate this object, select the center point, and then rotate it. There we go. And then you will want to bring out your units. So you want to bring out this one over here and bring out the other one over here. So now this is going to create you a connection between two nav meshes. So now this is going to allow you to walk through this space. This is exactly how you would create a logic for climbing up walls and such. So now that we have created one, make sure you move this aside like this, so you have one place where to pass it, and then Alt and drag for another one. Whoops. You will see that the boxes themselves, the cylinders, are disappearing whenever you deselect them, but don't worry, they are still there. You can see that in your world outliner that there's already 3 nav links. So make sure you create a bunch of these so that there are more places where the character can basically pass. Also make sure that your nav proxy links are set so that they are inside of this nav mesh. So as of right now, they are hanging a little bit in the air. So select all of them and move them down just like so. So now it's going to allow us to get to the other side. So let's give this the final try. And that's basically going to be it for these videos. Hope you enjoyed it. Hope you found this useful. And yeah, see you in the next one. There we go.